welcome everyone. Today we have our another new episode and we will discuss on quantum computing. We have our world famous speaker Professor David Smith and Mr. Anthony. First I would like to give chance Professor David Smith.
Well, Sharif, thank you. This is a topic that's close to my heart. I actually had the privilege of way back in 1993 doing the first quantum computing roadmap and forecast for the United States government and have been real involved with them ever since. Quantum computing, though, is a very, very interesting area. It's an area of computer science that uses the principles of quantum theory, and quantum theory really explains the behavior of energy and material on both an atomic and subatomic level. And quantum computing uses subatomic particles such as electrons or photons, and it allows these particles to exist in more than one state. So, unlike a classic computer, it's either zero or one. With quantum computing, it can be a zero, one at the same time as well, and be able to work across areas like that. And some of the ways that this quantum phenomenon works is phenomenal, like superposition, entanglement, that these machines handle information really in a fundamentally different way to classic computing. Like our notebooks, our supercomputers, our smartphones, our laptops, and others. And why is quantum computing important? It is one of the next generation computing technologies. With the type of classic computing we have today, we're seeing computing technologies like quantum, like biological computing and photon computing coming along to be some of the next breakthroughs for different types of problem sets. Uh, why is it really important? Researchers have long predicted that computers can tackle certain problems, and particularly those that are using a large number of variables and potential outcomes, like forecasting weather, simulation, optimization questions. They can do these much faster than classical computing. And we're beginning to see practical use cases now develop in quantum computing. And what is very interesting is we now have several companies which are beginning to provide quantum computing as a service. And IBM is one of the leaders as you begin to see that. And you're seeing Google and Amazon and others begin to move into that space. And some of the early people in there were like D-Wave, but then Intel is now beginning to make chips based for supercomputing. I mean, for quantum computing. Microsoft is getting into space. Alibaba, Nokia, HP, Toshiba, others. That the bandwagon for quantum computing is really growing very strongly right now. And quantum computing really could benefit a lot into the fields of security, finance, intelligence, drug design, discovery, aerospace design, particularly utilities with like nuclear fusion and others, big data, and digital manufacturing. Uh, there's quite a few use cases going down there. Quantum computing can be used to crack the type of encryption we use today very rapidly. Companies need to understand that the whole area of cybersecurity is going to change as quantum computing becomes more available and to use it because of the type it is. In the United States, the National Bureau of Standards has now released guidance on what they believe are quantum computing safe cybersecurity approaches. That is something that particularly developing nations and others should take the time to invest and look at and see if these type of cybersecurity protocols built around the beginning to be much wider use of quantum computing can be applied to them. And I think, Sharif, that might be a good introduction. I'll come back and talk a little bit more about some of the use cases and some of the other elements a little bit later. But Sharif, I think that's a good initial start.
Thank you, Professor David Smith. Mr. Anthony.
Yes, I mean, quantum computing, immediately quantum, it brings us back to Dirac, Heisenberg, and Schrodinger, the quantum world. the founding fathers of quantum mechanics and so forth. If I could just mention this very briefly, I mean, we go now to the particle accelerator. As a result of the particle accelerator, we discovered the Higgs field, the Higgs particle. We now know that empty space is not empty. That empty space is not empty. There's an invisible field everywhere in the universe. There's an invisible field everywhere in the universe. We live essentially in a giant cosmic superconductor. Space and time is an electromagnetic field, 0-point electromagnetic quanta. So we have these virtual particles that are popping in and out of existence all the time. These virtual particles that are popping in and out of existence all the time. This can only happen within the quantum world. It couldn't happen within the classic world, our world, because it would violate the laws of energy. You can't produce mass where you didn't have mass in the first place. So we live in a giant cosmic superconductor. There's an invisible field everywhere in the universe. And this invisible field represents and basically represents all of reality. Now, through this, in fact, once you apply the laws of quantum mechanics to gravity itself, space itself becomes a quantum mechanical variable and literally fluctuates in and out of existence. So once you apply the laws of quantum mechanics to gravity itself, excuse me 1 second, sorry. So yeah, basically, once you apply the laws of quantum mechanics to gravity itself, space itself becomes a quantum mechanical variable and literally fluctuates in and out of existence. So it's an incredible thing, this whole world of quantum mechanics. So we're talking about now subatomic particles, strings of light that oscillate. Everything within the universe oscillates. To be means to resonate. So we're talking about quarks. We're talking about gluons, which make up composite hadrons like pion, proton, and neutron. So it's a remarkable discovery, the Higgs field, the Higgs particle. And I, as you know, I'm a theist, so I go into quantum theology, because a lot of atheists will use this to say that God doesn't exist. So I go into quantum theology, as you know. So through this discovery, we know that there's an invisible field everywhere in the universe, the Higgs field. And through this, it's revolutionized our understanding of the cosmos. It's revolutionized our understanding of the universe. And of course, revolutionized our understanding of ourselves in terms of metaphysics. We now know that everything is to do with frequency. Everything that appears to be solid and real around us is all based on frequency. If you amplify the frequency, you change the structure of matter. So matter, in a sense, is an illusion. So it's all based on frequency. So through this, it's revolutionized our understanding of the cosmos. It's revolutionized our understanding of the universe. And of course, it's led to technological advancements like quantum computing. Now, when you're dealing with quantum computing, you're dealing with very high-level mathematics, algebra, very, very high-level mathematics. You're then going into quantum entanglement, basically information transfer from one photon to another instantaneously. As a science fiction writer, I speak a lot about this quantum entanglement and teleportation. Being a science fiction writer, I've dealt with this immensely. So it all really started with the discovery of the Higgs field, the Higgs particle, as I said, which has revolutionized our understanding of the universe and has led to technological advancements within quantum computing and so forth. And being a science fiction writer, I've written many things that gravitate around this particular subject because it's a very powerful subject. And when you're dealing with quantum mechanics, it's one of the most complex things that you could possibly tackle. It's a very highly complex mathematics, highly complex mathematics. So in summary, we've now discovered that the universe is a giant cosmic superconductor. There's an invisible field everywhere. Empty space is not empty. Every single point in space contains information. As I said, once you apply the laws of quantum mechanics to gravity itself, space itself becomes a quantum mechanical variable, literally fluctuating in and out of existence. It's a remarkable subject. It's fascinating, highly complex. And through this, we've now entered into quantum computing. It's revolutionized our understanding of the universe, the cosmos, metaphysics, and so forth. So I think I've said enough for that initial introduction.
Thank you. Mr. Martin.
Thank you.
How's it going? I'm just popping in and checking out what's going on here. Y'all are having amazing conversations as always. And I hear that the gentleman that just spoke was a science fiction writer, and I'm definitely a science fiction fan and all of that. I'm oftentimes amazed at the things that have been predicted in the science fiction that actually are reality. I know that a lot of the early science fiction had things like cell phones, had things like augmented reality, had things like virtual reality.
I'm going to have to send you some of my material. I'm going to have to send you some of my books.
Please
I'm going
do.
to
I
do that
look forward to
today.
getting those books and everything because that was actually the
In
quick
fact,
question
I'm going to
that you
use this today. I'm going to mention some of my stories in today's discussion. I think
Okay,
it's a good
cool.
opportunity to share afterwards.
Yeah, I'm looking forward to hearing about these
Great.
stories and everything. And that's one thing I was curious to ask both of my fellow guests and everything is how much of the world of fiction is actually the world of reality. Because definitely that's
Absolutely.
one of the conversations that goes on. I was actually having a conversation yesterday with a friend or a new friend on the internet, and they were actually making the argument that maybe we are getting to the point where everything is virtual. And I was arguing that no, I
Yes.
still like to go out and walk in nature. I still like to go out and go to concerts. I still like to go out and do a number of things that you can't
Well,
in the
in a
virtual
sense,
world.
everything is virtual
Don't have
because
the
we
same
now.
kind of
Yeah.
flavor as you do when you're doing it in the real world. So, like I said, you can fish in the virtual world, but I don't know that the fish that you catch is going to be as good as the fish that you actually catch when you are actually out in the sea or the pond. And I am not even a fisherman, but I was just using that as an analogy. But are we heading to too much of a virtual world? I guess is the question I've got to ask both of you since it was asked to me.
Okay.
Excellent, excellent. Professor David Smith, you are also working with NASA and you are working with many big companies around the world. So, how does this kind of innovation happening? Because my audience from Asia Pacific and South Asia, uh, I am working for developing nation. There are many young and talented pool. If they know your story and research lab story, they will be inspired, and you definitely will be happy. World Talent Economy Forum, we are integrated through Dhaka University and BUET. Dhaka University, you can say it's the Oxford of South Asia. 40,000 students they have. So our story become more interesting, especially for the youth community.
Oh, it's always great to see students and scientists and other researchers get involved in areas, particularly where they are in the uh, growth cycle of quantum computing. Because quantum computing actually has been around for a while, just not in a way that we can do it. And many times it was called quantum-like. But we're now beginning to see the market begin to take off more. Like I mentioned earlier, we're seeing companies like IBM and Google and others make quantum computing as a service available so that anybody around can begin to use these type of quantum computing capabilities, whether they're in a developing nation or a developed nation, to begin to use it. And when you begin to look at things like quantum machine learning, quantum simulation, the parallelism, cryptography, really very advanced algorithms. Those are all areas where, uh, with quantum computing as a service, it can begin to really work and begin to understand the differences. The marketplace, though, is really growing a lot. But to come back and talk about it a little bit more uh, from a technology view, there's really three different types of quantum computing, and there's one called a quantum annealer. And this is the oldest of the quantum computers, and it goes back to the early D waves and others like that. And a quantum annealer is defined to be a generic solver for optimization problems. It's oftentimes it's called, and the people I work with in quantum technology, it's quantum like because it is not a true quantum computer. The second type is analog quantum computers, and they help address physical problems that are way beyond the ability of classic computing. Quantum simulators have helped solve some of the toughest biological and biochemistry problems that you see today. And they are really, like I said, really good at areas such as simulating a protein and how proteins fold. And this is a problem that will bring classic computing to its needs because of the fact that I said before, classic's either 0 or 1, where with quantum it can be in all three states at one time. But where we're really headed with quantum computer is what is called universal quantum. And it's the really the most powerful type of quantum computing that's going to be there, and we're still probably about 8 to 10 years away for beginning to see universal quantum computing begin to be used across the marketplace, and to see them in everyday use probably at least 10 to 15 years away. And this type of applications are going to be really good there. The analog quantum is really a high area of computational, but universal quantum computing really brings these all new benchmarks that we're going to see there. And it's going to change many of the different ways we're doing it. And there's actually a race right now for quantum superiority across it. And many different countries are playing in that area, and many different companies are trying to get into that as well, and it's going to be a very, very important uh, benchmark for who can do it. Because, for example, you heard me before talk about how quantum computers can break today's advanced uh, crypto keys that are used to secure information, and do it very, very rapidly. Well, we're going to need the same thing going back and being able to secure it. Um, the question on there, would quantum be effective at replacing predictive systems? Well, quantum can take the applications that are used for predictive systems and make them run faster if they are number-based predictive systems. If there's algorithms driving it. If it's a predictive system that does many, many different parallel paths at the same time, then quantum might not be the best, but more of a neural network type of approach or a biological computing type approach might be better, as we look at the question that Ted has asked as part of the answer to that. But quantum is going to change the way we do things once it becomes generally available. And it's something that schools, entrepreneurs all need to follow. And the general availability of quantum computing as a service is going to make it affordable all around the world. So, Sharif, I hope that answered your question.
Mr. Anthony.
Yeah, just very quickly, because Mark asked the question about the nature of reality. As I said, very quickly, I'll just touch on this because we've discovered that the universe is a giant cosmic superconductor. Basically, there's an invisible field everywhere in the universe where you're having virtual particles popping in and out of existence all the time. As I said, this can only happen within the quantum world. It couldn't happen within our world because it would violate the laws of energy. You can't produce mass. We didn't have mass in the first place. So this only happens within the quantum world. Virtual particles that are constantly coming in and out of existence. We're talking about subatomic particles, strings of light that oscillate. Everything within the universe oscillates. Everything is based on frequency. Everything is based on frequency. So when you break these subatomic particles down, you're talking about quarks and gluons, which make up composite hadrons like pion, proton, and neutron. So everything, all of reality, can be defined by quantum mechanics. All of reality can be defined by quantum mechanics. These virtual particles that are popping in and out of existence. So what appears to be real around you is actually nothing but just an illusion, in the sense it's all to do with frequency. If you amplify the frequency, you change the structure of matter. So in a real sense, we are actually living in a virtual reality, just based on the notion that we're living in this giant cosmic superconductor, that there's this invisible field everywhere in the universe. So in a sense, yes, we are living in a virtual reality, in a very real sense. In a
Well,
very real
Anthony, along those same lines, because I know that there's been a lot of talk in the wellness space about people that are very much interested in human frequency and their own mind frequency, and trying to fine tune their frequency. I've actually got a very good friend that is always talking about that space. He's actually a funk musician by his real trade and all of that, but he's very much into crystals and other things in terms of trying to adjust his frequency, and it will actually also have those conversations as well. So that's been something that's been talked about more recently. I think the pandemic got more people into that
Yeah.
wellness space and into that whole notion of frequencies and our own personal frequencies. But I was just wondering your thoughts around that, And if I can add something to that, I've always been one, and some people will take this as being almost science fiction like or almost non believable and all of that.
Mhm.
But I've always been one of those people that have believed that if you are feeling that you are in a dangerous situation, that if you sometimes move things around or you sometimes change the things, if you've got that deja vu feeling that you can actually change the course of what will happen. Like I said, some people will say that that is strictly science fiction and not realistic, and some people just say that it's a comfort tool and all of that. But I have seen in cases where I might have been in an environment that I didn't feel positive about, and maybe I had a dream about it the night before, and I might do something as simple as moving a phone or a salt shaker just to feel a little bit of a different frequency and all along those lines. But I was wondering your take on that, Anthony.
Space and time is an electromagnetic field. Space and time is an electromagnetic field, 0-point electromagnetic quanta. We live in a giant cosmic superconductor, this electromagnetic field. Now, I'm a theist. I believe that God exists outside of time and space. So to him, he can see the past, present, and future frozen in time and space as one. Okay? He can see the past, present, and future frozen in time and space as one. Almost like a Trinitarian perception of reality. The past, present, and future is frozen in time and space. He can see everything at once. But we who are bound by time and space, that live within this electromagnetic field, live in a Trinitarian perception of reality. Past, present, and potential future. Okay? Within this electromagnetic field. Okay? So this is something that I'd like to mention about as well from a theistic perspective. Because obviously atheists use the Higgs particle, the Higgs field, they call it the God particle, to say that God doesn't exist. But I believe that God works through quantum mechanics. I believe that God is working through quantum mechanics. Just because we've discovered this invisible field, these virtual particles that pop in and out of existence, doesn't mean that God doesn't exist. He's working through quantum mechanics. He's working through evolution. As I said before, when you apply the laws of quantum mechanics to gravity itself, space itself becomes a quantum mechanical variable. And an atheist will say, so through this, you can literally create universes, spaces, and times where there was no space and time before. But that's impossible because physical laws do not create physical realities. You need something more. And it's God that sets life into motion through quantum mechanics.
No, that makes sense. I guess
And actually, even through evolution. In evolution, if you can't explain genetics, you can't explain evolution, because evolution sits on the pillar of genetics. Richard Dawkins says this is a gap. It's a black hole for the atheists. Because if you can't explain genetics, you can't explain evolution, because evolution sits on the pillar of genetics. And no scientist knows how we had the first genetic molecule, a precursor to DNA and so forth, and then evolution started. So if you can't explain genetics, you can't explain evolution. It's a huge gap for the atheist. And as I said, if you're saying that empty space can create life, because what they say basically, because it's a giant cosmic superconductor, the universe is a giant cosmic superconductor, if you wait long enough, you are guaranteed by the laws of quantum mechanics alone to produce something out of seemingly nothing, because gravity allows for positive and negative energy configurations. So you can produce a universe from seemingly nothing because of this invisible field, because every single point in space contains information. That's impossible because physical laws do not create physical realities. Physical laws do not create physical realities. God has to be at the center of quantum mechanics. He's at the center of this virtual reality, if you like, because we're living in a virtual reality just based on the fact that we live in a giant cosmic superconductor. But it's God who's orchestrating everything through quantum mechanics. Not going away from the subject too much, because obviously this is about quantum computing. And through quantum mechanics, it led us to now understand the universe in a completely different way, and obviously led us to quantum computing, technological advances within quantum computing, and so forth. But as a philosopher, I touch on I'm very multidimensional. Very multidimensional.
Anthony, I appreciate that.
And if I could just squeeze this in as well, being a science fiction writer, and this is for Dave as well, because I'm going to send him a copy. Androids and the Gods. Do androids dream of the gods? In my book, Androids and the Gods. Do androids dream of the gods? It's basically about machines that start to develop a sense of spirituality, gravitating towards a theistic philosophy. So if a machine can develop a sense of God, spirituality and metaphysics needs to be redefined. The nature of man, the nature of the mind, and so forth. Then we need a new philosophy to explain what it means to be human. We need a new metaphysics. So my stuff is really, if I can say this as humbly as possible, is really groundbreaking stuff within the realms of metaphysics and philosophy.
Hey,
but anyway, we're here to discuss quantum computing. So I don't want
No,
to
and I was
gravitate
actually going
too
to get
much.
back to quantum.
We're going
I was
into a
actually going to get back
philosophical.
to quantum
We're going
computing
into
really
too much
quickly.
philosophy here now.
No,
So
I love philosophy as well, but I was going to
yeah,
get back to quantum
but
computing,
but
but also
androids and the gods, I will send you both a copy.
please do. I look
Definitely.
forward to getting that. But it's
Are you
actually
on
a question
Facebook? Are you
about
on Facebook?
I am on Facebook and I'm on LinkedIn. LinkedIn's probably
Okay.
the better way
Okay,
to
I'm
get
going
it.
to
Uh,
find you. Okay.
yes. Mr. Markley, yes,
Yeah,
please continue.
my quick question for everybody around this quantum computing is, there was a time because quantum computing can also help us, in my understanding of it, get around the world and even travel in different time and space continuums. Is what as they have said, quantum computing can help us with. There is always that dream if you follow science fiction of teleporting, and there was a time that people didn't want to get on a boat or on a plane, and I'm thinking that a lot of people won't want to have themselves dissolved and re-evolved as we put it in the science fiction world. But I'm guessing that quantum computing, if it goes the way that it should go,
It
will
uses
make people feel
entanglements.
more
Quantum
comfortable
computing is to do with
with doing
entanglements.
that. And I'd love to hear David's thoughts and Anthony's, because I'm thinking that at some point, us traveling, like maybe I need to go visit somebody in Spain and I just get beamed to Spain versus trying to catch a plane or a boat or whatever other means of transportation there are now to get there.
Well, Mark, you actually began to talk about other areas of quantum,
Right.
because quantum computing is just a small segment of the whole quantum realm. And for example, I'm on the board of a company called Quantum Machine Corporation
Okay.
that is using a quantum concept built around angular momentum to change the transportation industry, whether
Right.
it's in space, air, ground, or water. But what you were talking about is a concept called quantum teleportation.
Right.
And in the early 90s, in both California and up in New Jersey, quantum teleportation was demonstrated by moving an atom of photon less than a quarter of an inch. And that was the beginning of quantum uh, teleportation. Uh, it has progressed. Actually, the leader today in the world in quantum teleportation is China.
Okay.
And China has announced that they have quantum teleported things from the Earth to satellites in space. And to the China has two space stations up in orbit right now, and they have another one they're about to launch. And they have said that they have built those to test more quantum teleportation. Now, tele- quantum teleportation today is not ready for a human object. So it's not like beam me up, Scotty yet. Um, but quantum teleportation is very interesting because those objects can, just like we talked about quantum computing, where it can be a zero, one, or both. The same thing is happening when you look at quantum teleportation, is that it allows you to exist in multiple states. And you see that. But let's come back to quantum computing for just a minute.
Just really
Much
quickly, just a clarification, because I want to make sure I understand what you're saying. So I do remember a long time ago there was an experiment. I think it was Yuri Geller, the magician, that actually moved like a fork using his mind. So is that what we're seeing with this quantum computing
no.
level that you were talking about earlier? So they literally can move something from one part of the room to another, or from one place to another
Well,
as well.
think about it a little bit different. I mean, the example used was an illusion and did
Right.
not really involve quantum mechanics. It didn't really involve um, taking the state of matter and changing the state of matter and duplicating the state of matter, which is what uh, transport teleportation does. Uh, so they're very, very different as you approach there. The other thing that you've kind of alluded to there is multidimensional
Hmm.
uh, travel. And multidimensional travel is an area where it might be more like what Anthony's talking about, where more frequencies are involved, where particularly frequencies up in the terahertz range might be enabling parts of that, where quantum teleportation is yet still a different. And could quantum teleportation be used in conjunction with other technologies to do things like what you asked? Yes, but that's still in theory as we're working through it. There's some advanced work being done in those areas. Much of it's classified, but
Because it almost sounds, to
you
come back
see
to
those.
Anthony's point, it almost sounds like what religious people describe as an out of body experience. And I don't claim to be the most religious person, but I do have friends that are very religious that have claimed that they have had out of body experiences where literally their body or their spirit was leaving and they were able to see whatever was around them. I know one very good friend that claimed he had that experience several decades ago and all of that. And I know others that have had it more, probably more recently. But that's what it almost sounds like y'all are talking about. But I'm just trying to get a more layman understanding.
Well, it kind of is. Again, you're talking about an area that is very system oriented. And
Okay.
Mark, you've heard me talk on Sharif's programs many times
Right.
that we live in a world that's governed by systems of systems theory, and that everything today has moved from a discrete application to a system all the way to systems of systems theories today. And I'm at a conference, Digital 360 Summit, where yesterday I actually in the panel got to talk about systems of systems theory as part of this and how fundamentally it changes the world when we look at communications, when we look at smart cities, when we look at energy and other things like that. Well, quantum computing is going to change a lot of the world, particularly when it comes to things like digital twins. Mark, you've heard on these different broadcasts how important digital twins are as we go to the future,
Right.
and how that modeling and simulation really helps us begin to move faster. And one of the biggest challenges today in the world is we need to increase the speed of innovation. And we need to increase the speed of innovation by using group intelligence, and particularly group intelligence at a distance. You know, today, geography is not a point on a map. Geography is where you have the competencies and capabilities to innovate and do the things you want to do. And tools like quantum computing are going to really help us do that, particularly since most of the quantum computing uh, available today that is available to the general public is these quantum computing as a service, like you see IBM, Microsoft, Google, Amazon, Intel, and others bringing to the marketplace. Um, and those type of things really are going to help you get there. But today, the biggest driving factors in quantum computing is government funding still. Yes, there's quite a bit of commercial, but government funding still uh, really is the top there. I mean, for example, in the EU, Germany Federal Ministry of Education Research last year put a massive investment out to build a unique type of quantum computing in the 10 qubit range in Germany that's called a qubit iron trap, which is another way to get. You're seeing many alliances being put in place with companies, universities, governments, non-government organizations and things coming together to try to advance it. But when you look at quantum computing, particularly Mark, there you have to look at the hardware side, which is most of what we've talked about today. But there's also a software side to it. The programs that run on classic computers are not written to take advantage of the unique characteristics of quantum computing. The fact that a state could be zero or one or both. It's not. They're not written to take advantage of the immense speed. Quantum computing can do something in a second that would take hours or days to do in a classic computer. But the
Right.
software has to be written differently. The ways you interact with it have to be uh, different. Also, there's some problems with quantum computing today, particularly as you're going to general quantum computing with stability and error correction. It We understand error correction really well in classic computing today, and there's a great breadth of science on that. But one of the places, Dr. Sharif, where developing country universities and things could work on a lot is the software side. How do you do this type of error correction? How do you do it in situ where you can take advantage of the speeds and not have to do it as an external process that's coming back because it's so different. And the in situ side of quantum computing still has a long ways to go with it and opportunities to do a lot of things in there. You're also beginning to see something called quantum safe, which is using the intense power to really up the encryption that can be used. And those are some of the things that will be in very future generations, probably version 4 or 5 of some of the blockchain things like we've talked about here last week, Sharif, and how we go there. But there is really a lot of areas where you can work in the quantum computing realm. Quantum computing hardware, very expensive. And to research, very expensive to build and deploy. Quantum computing software, quantum computing use cases and applications, reasonably inexpensive today to work on because, once again, we now have quantum computing as a service. We now have governments making available quantum computing capabilities to research universities and others like that. You have programs like Intel, Qualcomm, Microsoft, and others where they are funding entrepreneurs to come up and develop applications that can be run on quantum computing. And you're going to really see it there. Yeah, Virginia's comments are just really so important right there, is because it's going to help make fundamental changes in engineering, fundamental changes in transportation, food, and natural resources. Quantum computing are going to be able to give us new approaches and new simulation tools and the creation of very complex digital twins to help us deal with climate change, to help us deal with the complexities of energy distribution like we're seeing today. And water is going to be one of the next big challenges, and we need greater capability than we have on our current supercomputers to begin to work the simulations and models of that. So this is going to usher in a whole new era of scientific analysis, a whole new era of policy analysis, and new approaches to manufacturing. You're seeing companies like Mercedes beginning to use quantum as a service to begin to come back and model more efficiencies in factories, more efficiencies in designing cars and things, particularly as they begin to transition to more electric vehicles, as they begin to start designing hydrogen powered vehicles, which I believe will be the next one after EVs and probably will replace electric vehicles going forward. But you need the capabilities of the massive computing capabilities of quantum computing to really do the modeling, simulation, and optimization that's going to be necessary for each one of those. So, Dr. Shu, I hope that answered.
Mhm.
Yeah,
Excellent,
that
excellent.
answered a lot
Well,
of the
Mr.
questions. But
Anthony,
I
yes.
mean, certainly quantum computing is an incredible thing, and as I said, it's such a complex world because you're dealing with highly complex mathematics. As I said, all mention the word quantum, and straight away you're talking about very highly convoluted mathematics and so forth. But certainly, quantum computing will revolutionize the world, as Dave said, in multiple ways. There is no question about that, and it's something to look forward to because there's so many applications that it can be used for, as Dave said, and it's something to look forward to in terms of the future. Now, mentioning the future again, as a science fiction writer, if I may, just bring in some of my work into this wonderful conversation that we're having. I talk about robots in the future in many different ways, advanced machines in the future. For example, in the future, one of my stories, Mind Blitz, I talk about how in the future we'll be mind controlled by machines, how robots effectively will take over man and will have a nanochip implanted within the cerebral cortex of the brain. Most of the brain is made up of cortex, a nanochip implanted in the brain, and this nanochip has the capacity to extract all encephalic activity of the brain: memory, emotion, thought, electrical and chemical activity of the brain. Everything that is registered within the brain is registered on this nanochip. Okay, which again, it's a very futuristic idea that I've had, and it's all controlled by machines. Implanting a nanochip into the human brain in the region of the brain known as the cerebral cortex. Most of the brain is made up of cortex and so forth. And through electromagnetic radiation signals, it's able to collect all the information that's stored on the chip, and then it's downloaded into a giant computer for government consumption. So we're talking about mind control in the future, because I write a lot about how artificial intelligence it could be used to mind control us and so forth. So some of my science fiction stories are very colorful and in some ways very frightening as well. So this story is a story that I wrote actually in book two. It's called Mind Blitz. It's in a world where your thoughts and ideas are no longer your own. People that set out to conceal them are deemed evil. So basically, they completely control your mind via this nanochip. And through electromagnetic radiation, they collect all the information on the nanochip, and then it's all downloaded on a giant computer for government consumption. So they can see exactly what you're thinking in every sense of the word. So your complete brain scan. And obviously, this can be done by understanding brainwave patterns. And also, as you know, I mean, a new breakthrough when it comes to understanding neurons is algebraic topology. Through algebraic topology, we can now understand a lot more about how neurons work and understand the brain more and so forth. So, why science fiction stories are, in some ways, advanced machines of the future, and it can be somewhat scary in some
No, it
senses.
sounds scary. It almost sounds like Borg and all of that from
Yeah.
some of the earlier science fiction episodes of, I believe that was Star Wars, or was that Star Trek? It was one of those. But definitely, just one of the questions I had to both of you, David and Anthony, is the early computer. Like the early computer was basically covered an entire room, like probably about the whole size of my bedroom and everything. That's the size of the computer, and it was also not that much affordable to the general public. And then computers became much smaller, and now just about everybody has a laptop, and all along those lines. At what point will quantum computing and quantum physics be available to the common person? Because, like I said, I do remember the early days of computing. I went to school in the '80s, and we still had some of those big computers and the floppy disk and all of that. But then now everybody's got a laptop, and in some cases, not this one I'm on now, but in some cases they're relatively small, and you can even have a lot of computing done on your phone and all of that. So, at what point will we see this quantum computing be able to be affordable to the general public? Because I think that's the concern that most people have, is that when you talk about these things that are very high advanced, the common man wants to know, at what time can I have it?
Thank you. Uh, Professor David Smith, what's your concluding remarks for today's session? And if you give some sort of good example from industries and industrial research, maybe our audience can uh, take some note and they can do some research specifically for quantum computing.
Well, Sharif, you've just asked a question that is this wide as you begin to go through and look at the applications of quantum computing. So let me give you a few as we look at those and how they can be used. One of the big areas where you've seen early application of it is in the pharmaceutical industry. And the pharmaceutical industry needs to look at all the proteins, all the interactions, and other areas that can happen there. You begin to see it used in the energy business. ExxonMobil is a great example of where they have really availed themselves of quantum computing to look at how to look at formations, to look at other ways to begin to extract, to be able to go back and be able to be less damaging as they begin to do drilling and other type of things, and how to optimize their supply chains. You're seeing financial institutions beginning to use quantum computing to design more effective, more efficient investment portfolios, for example. You're seeing it being used to design new ways for security. The healthcare industry is beginning to use quantum computer to develop new genetically targeted medical care, to look at other things. It's going to really be able to power very, very advanced DNA research, very advanced RNA type of research. Uh, you're seeing quantum computing used in forecasting weather. You're seeing it used in building safer aircraft, in air traffic planning, ground traffic planning. You're beginning to see it being used a lot more. Uh, Gartner predicts that 40% of companies, of large companies, will be having initiatives around quantum computing by 2025. And, that's a healthy number from where it was this last year and beginning to go there. So, you know, a concluding remark is really companies today, universities today, consumers today need to follow the developments of quantum computing. If I'm a company, I want to look at ways to make sure as I am looking at the future of what we're doing, that quantum is taken into account going forward. Not only quantum, but other areas like biological computing, which is probably has a lead lag relationship with quantum computing by about a decade. Uh, and you're seeing that going through. Uh, the other types of quantum things, like what Mark brought up earlier, is going to be one of active development and one where there's going to be a lot of funding opportunities as well. Uh, but I would encourage, particularly the students you're talking about, Sharif, and I would encourage the researchers, particularly in developed nations, to avail themselves of the grants, avail themselves of the programs where they can go in and access some quantum computing at a limited amount for free initially. And then as their projects develop, go into a low cost quantum computing as a service to go that way. And again, there's opportunities in software and hardware and applying it to business cases, to applying it to entrepreneur activities. One of the biggest growth areas of the last 6 to 10 months has been trying to use quantum computing to optimize everything, to optimize shipping, to optimize logistics, to optimize manufacturing flows and things. And that's an area where domain knowledge is very important. So, great area for entrepreneurship. So, Sharif, I hope that answered your question. But this is a topic that is very important to everyone today.
Absolutely.
Thank you.
Well, I
Mr.
think
Anthony.
Professor David Smith has wrapped it up fantastically well. Quantum computing is the way forward. I mean, it's, as I said, it's going to revolutionize the world in many different domains. As he mentioned, within the medical sphere, in many different spheres of endeavor. So it's certainly the way forward. And as I've mentioned before, robotics, artificial intelligence is the way forward. If we're going to colonize Mars and so forth, it will be down to the machines that take us there ultimately. So for me, basically, I would say yes, absolutely. I mean, quantum computing is the way forward. It's an incredible, exciting thing all round, and artificial intelligence is the way forward. We're living in a computer world, essentially, and if we're going to colonize Mars and go into the cosmos, it will be down to robotics and highly complex machines and so forth. And as a science fiction writer, I finish with this. Anyone who's watching the show, I would definitely check out some of my stuff, Androids and the Gods. One of my best books, Androids and the Gods, and my latest book, The Golden Moons of Jupiter, where I do speak a lot about artificial intelligence and complex robotics in the future and so forth. So please, if you get a chance, check out some of my material. Thank you.
Thank you. Mr. Markley.
No, I think it's been a great conversation. I've definitely learned a lot and continue to learn a lot here on this show that you do a great job of and all of that. And I look forward to being back on another show, like I said, on these shows that deal with quantum and some of the more science fiction material. It's not always in my expert lane and all of that. But like I said, I do love learning and learning from experts such as Anthony and my good friend, Mr. David Smith, and all of that. So always glad to do that. And like I said a couple of times with some of the questions that I was asking, I definitely think it is something that is needed to be learned about because it will probably have, as David alluded to, a direct impact on a lot of our lives. So I know that there were probably a lot of people that were not thinking about what the car would be doing to our society in the time that we were in horseback and all along those lines. Just like there were probably people that were not thinking about the impact of the airlines before the airlines and the airplane became so common and all along those lines. So sometimes when these things are in their very much more of the academic kind of environment and some of what some people might consider the highfalutin environment, I do think that people like your students and others need to learn about it because it will definitely impact us as we go on in the future and all along those lines. I'm definitely just hitting the big 60 in July. And, you know, by the time I'm 80, some of those things, which would be close to my dad's age, I think he's actually 82 and all in that space, that being that a lot of those things that will be needed in that lifetime or in that time when I get to that age, and hopefully I'll make it to that age, will be very much a commonplace. So some of these things that we're talking about that seem very theoretical right now might not be as theoretical as we go further and further in time. David even alluded to the fact that we're seeing some of the applications of quantum mechanics and quantum computing in our restaurants, in our hospitals, and in a number of other places that we have to deal with on a regular basis. So it does seem like it is something that we need to be informed about and need to keep our eyes on. That oftentimes we don't keep our eyes on. And just as a last note, I will say that one of the things I love that you're doing and that the network is doing is bringing attention to a lot of these issues because too often our school systems are not paying enough attention to these things and they need to pay greater attention, and that's where I'll land the plane because I just definitely think that we need to definitely try to make it more of a thing that not just the folks that are in the field understand, but also the general public understands as well.
I'm gonna contact both of you via Facebook and send you some of my material. By the way, okay? I'll do
Please
that
do.
straight after the show with pleasure.
Okay.
Fantastic. Thank you.
It's
And
been a
thank you,
real pleasure,
Sharif.
Dave. It's been a real pleasure, Sharif and Mark. Thank you.
No problem.
Fantastic
Thank you.
discussion. Thank you.
Thank you, everyone. And this is really interesting discussions, and definitely it's a very important for our audience, those who are actually from South Asia and Asia Pacific. And beside that, I just want to share that World Talent Economy Forum, we are developing our lab. We are developing lab with largest university, with governments, with corporations, with cities. So those who are interested to join in our lab, it's like open source mode. You can integrate it with World Talent Economy Forums lab, and you can solve many real projects. So we are not running behind science fictions. We are running behind more real projects. So hopefully your contribution can change millions of people's life. And thank you, everyone. I request all of our audience, please share our content as much as possible. And especially, I want to give thanks that how I uh, get support in South Asia when I launching this World Talent Economy Forums in South Asia. And especially, I want to give thanks the university, the corporations, the academic people, and the people from different cities, those who supporting our projects. Thank you. Bye bye, and take care.
Thank you. Thank you.